So let us now look at the second theorem, which is crucial for solving the problems in this chapter. And this theorem says that if you take an exterior point, say P, and if you draw tangents to a circle, then you can get two tangents, PT1, PT2, which is kind of obvious, right? If you have external point, you can only have two tangents. And these two tangents are equal in length. So the length of the tangent is taken from the external point to the point of tangency. So PT1 is equal to PT2. Let me repeat. The theorem says that if you draw tangents from an external point, you can draw two tangents and both these tangents will be equal in length. Further, it also says that the angle that it makes with the line joining the center and the external point, that angle with the tangents make, which the tangents make with the line joining the external point and the center are equal. In other words, the tangents are equally inclined to the line joining the external point and the center. Okay. Next, something else which can be deduced from this result is also that the angle that the tangent subtends at the center. Remember, to subtend means to throw. So this tangent PT1 throws this angle at the center. See, just join the ends of the tangent to the point O. Then that is the angle subtended by the tangent to this point. So that is the angle subtended by the tangent to the point O. Similarly, PT2 subtends this angle, and these two angles are also equal. So that's what the theorem says. Let me sum it up. Number one, it says that from an external point you can draw two tangents which will be equal in length. Number two, it says that these two tangents will be equally inclined to the line joining P and O. And number three, it says that the two tangents will subtend equal angles at the center. So how do we go about proving it? It's extremely simple. We take the two triangles. We say in triangle PT1O and triangle PT2O, angle T1 is equal to angle T2. And why is that? Because we know that from the previous theorem that the tangent is always perpendicular to the radius at the point of tangency. So we can say is equal to 90 degrees. Then we say OP is equal to OP. Why? Because it's common. Okay. So we have the hypotenuse, which is common, 90, 90, and quite obviously OT1 is equal to OT2 because those are the radii, right? So these two triangles will now become congruent by the RHS rule. Therefore, triangle PT1O is congruent to triangle PT2O by RHS rule. Now, once they are congruent, you will get the corresponding parts of congruent triangles are congruent. So you will get PT1 is equal to PT2 as your first result. Angle T1PO is equal to angle T2PO, that is these two angles, and they are also equal. And lastly, we'll get angle T1OP is equal to angle T2OP, these two angles, and they are all equal. Why? Because corresponding parts of congruent triangles are congruent. Alright, so that's the proof for this theorem. So these are the two theorems which we have to use to solve various problems. First one, that a tangent is perpendicular to the radius at the point of tangency. Second one, which says from external point the two tangents drawn are equal. They are equally inclined to the line joining the point and the center, and both the tangents subtend equal angles at the center of the circle.